s-enn has already shown in many projects that it's not just a functional form of sunshade, but that s-enn can also be used as a design feature on building facades. With its elegant stainless steel appearance, it satisfies the highest of aesthetic demands from both architects and clients. As an externally fitted sunshade, s-enn is especially effective in reducing the amount of heat that gets in, without in the process impeding the view of those inside looking out. Externally fitted shading systems do, however, certainly have the drawback of being at the mercy of the full force and whim of the weather, which is why many systems have to be wound in as soon as winds reach even a modest speed and quite often get damaged. On high buildings, an externally fitted sunshade is generally not possible at all. This is where s-enn is able to show its strength to the full. s-enn has been specially developed for use in strong winds and can thus be used even on high and exposed buildings. In order to prove s-enn's capabilities in relation to wind speed, a near real-world test was performed in the huge wind tunnel at Daimler's factory premises in the Untertürkheim district of Stuttgart. This wind tunnel is so big that, for example, even complete commercial vehicles can be tested here for their aerodynamics. The tunnel's dimensions were therefore large enough to set up a container we'd prepared, designed to simulate an entire building facade and, above all, the corners of a building which are especially exposed to the wind. s-enn was then fixed to the container facades in a variety of configurations. s-enn was tested with the wind blowing from 3 different directions: wind impact from the front, diagonal wind at an angle of 45 degrees and wind blowing in from the side. According to building aerodynamics experts, it's in particular wind that hits a building at 45 degrees that represents a critical situation. All of the tests were carried out both with s-enn static in its fully extended state and while being run in and out. The wind tunnel's maximum possible test speed with our setup was 126 km an hour. It's important to bear in mind here that a wind speed of around 70 km an hour is a fresh gale in which large trees sway, window shutters get thrown open, twigs break, and the wind represents an appreciable hindrance to anyone walking. Between 75 and 88 km an hour, it's a strong gale in which larger branches break, minor damage is done to houses, roof tiles get blown off and garden furniture flies around. At a wind speed of 89 to 102 km an hour, we are already talking of a full-blown gale. Trees get upended and houses suffer serious damage. Winds of this strength are rare in inland locations. At up to 117 km an hour, the prevailing weather is a violent storm in which cars get blown offline, serious damage is caused to woodland, and walking is impossible. Winds at any higher speeds are called hurricanes, which cause extreme storm damage and destruction. To make conditions even more real, a second series of tests was run with a wedge positioned in front of the wind tunnel opening in order to produce turbulence and thus simulate strong wind flurries. s-enn successfully came through the tests in all wind flow situations, up to a speed of 126 km an hour. The s-enn systems remained completely functional at all times. The permitted wind speed above which the wind monitoring control system has to draw in s-enn shades has therefore now been moved from the previous 55 km an hour to a new level of 90 km an hour, which equates to gale force 9 to 10 on the Beaufort scale. In addition to long life, a low tendency to get dirty, outstanding energy reduction, and an impressively transparent view through to the outside, s-enn is now able to score with another major benefit: extremely high proven wind resistance.